approach. Whatever the incident, approach from upwind, uphill. Position vehicles facing away from the incident and assess the situation. Do not rush in, or you may become part of the problem. As first arriving officers, you will be confronted with many response objectives, all important and all needing to be done now. These objectives include ensuring the safety of personnel from all emergency service agencies, as well as the community. Isolating the incident and securing perimeters, that is, establishing and controlling hot, warm and cold zones. Establishing command and control, notifying your agency about the incident and, of course, liaising with all other agencies. Rescue, ranging from those who are immobile to those who self-evacuated. Avoiding secondary contamination, both on-site and off-site, either by people, equipment, or agent spread. Triage, medical treatment, and subsequent transport of any casualties. Securing the evidence and preserving the crime scene. Protecting against possible secondary devices. Management of the incident, that is, stabilizing the incident and eventually making the incident safe. Agent identification. Management of off-site effects. These are the impacts on the broader community, such as road closures. In many instances, you cannot implement all these objectives at once. However, you can implement the key objectives, often concurrently, and undertake activities within your capabilities. These key objectives include recognizing the incident, isolating the area and establishing command and control by implementing the incident management system used within the jurisdiction. Assessing a CBR incident is no different to any other incident. You will want to know what is it, how will it get to me, and how will it hurt me. So remember, before assessing the incident, stop, think, and be safe. The purpose of the assessment is to determine the problem, the materials involved and their properties. Determine all the hazards the materials and situation present, and determine the risk to people, property, and the environment. Simply, incident assessment or size-up might be described as: what is it? Where has it come from? Where is it now and who is it affecting? Where is it going and who will it affect? And what might affect it? In the case of a CBR incident, remember the incident signatures previously described. If you are not familiar with recognizing a CBR incident, then review the section on recognition of a CBR incident. The earlier the incident is recognized as CBR, then the earlier the incident controller can determine the appropriate response and assess how various actions might affect the incident. At all times, beware of other hazards, such as secondary devices, especially near where responders are positioned, and always remember the site is a crime scene. The incident assessment is used to develop a plan to manage the incident, often called an incident action plan, and determines which priorities are implemented, how, and by whom. The incident action plan addresses many elements, including response objectives, a site safety plan, the types of hazards likely to be present and action levels, communications plans, areas where PPE is necessary to work, the types of activities to be undertaken, where, how, and when, and what PPE is required. The plan should be reviewed continuously and shared widely with emergency service personnel to ensure their safety. No entry operations should be undertaken unless there is a plan that addresses these issues, including personnel safety, personal protective equipment, decontamination, the equipment required to complete the task, what to expect, and what to do in an emergency. Containment objectives. After recognizing a CBR incident, one of the initial objectives is containment or isolation of the site. This also includes the airspace. The site is isolated to limit the number of public and responders that are exposed to the CBR agent and prevent the spread of the contamination. This includes those already contaminated and those seeking to offer assistance. Many factors influence the size of the isolated area, including incident size and the stage of the incident. Responder resources such as personnel, capabilities, equipment and detection equipment. Environment, location and occupancy. An incident can either be an outdoor release that impacts an indoor site or vice versa, and can quickly overcome a population. Indoor incidents involve enclosed spaces with a mixture of natural and artificial barriers like doorways, which will affect operations and the movement of casualties from the site. An outdoor release may also involve enclosed spaces with a mixture of natural and artificial barriers. Sometimes responders, because they can see the effects on the public, react before properly assessing the incident and setting up or wearing appropriate PPE. Outdoor incidents. For outdoor incidents, approach the incident from uphill and upwind and secure the immediate area starting from upwind and uphill. Secure what you can control, but remember it is much harder once operations begin to increase the size of the isolated area. Use natural features such as trees, valleys, intersections, the topography and built features to assist making site isolation easier. Indoor incidents. Initially, isolate the external area around the entrance, taking into account the release, weather, and topography. Then, secure the main entrance doors and any secondary exits or entrances such as fire escapes. Using local knowledge and building maps or plans if available, secure the air handling system so that spread within the building is minimized while people evacuate. Secure the immediate area around the hazard and then the room. Next, secure the adjacent rooms and the entrances to that particular floor, that is, the lift well and stairwell. The adjacent floors should then be isolated, and finally, the building. Containment zones. The secured area is further subdivided by establishing cordons, and the police will define an inner and outer cordon. The outer cordon is the line at which general access to the site is restricted, but access of equipment, resources, and authorised personnel is permitted. For other agencies, the outer cordon usually corresponds to the cold zone. The inner cordon is the line at which only personnel undertaking specific activities within the contaminated area are permitted. For many agencies, the inner cordon corresponds to the hot and warm zones. Secure entry and exit points for each zone need to be established, so only authorised personnel can work in these zones, and emergency entrance and exit points are established for an emergency. Generally, the incident is segregated into 3 operational zones, and so that we're familiar with these zones, they are defined here. The hot zone. The hot zone is the area immediately surrounding the source of the release of the hazardous material. The size of the hot zone is based on the hazards to life, critical systems, and property. Use natural features such as trees, fences, and establish controlled entrance and exit points, emergency exits, and select PPE suitable for this environment. It is important to apply sound criteria to define the extent of the hot zone. Each jurisdiction will determine the appropriate criteria, but for a chemical incident, often the IDLH value is applied, and for a radiological emergency, the value 100 microsieverts per hour is applied. There is no equivalent value for application at a biological incident. Warm zone. The warm zone is the area immediately surrounding the hot zone and is the area in which decontamination is conducted, and some functions to support operations in the hot zone are located. When establishing the warm zone, use natural features such as trees, fences, and establish controlled entrance points, emergency exits, and a refuge area for the casualties, and secure a large area for the decontamination corridor. The refuge area may extend into the hot zone. The personnel working in this area need to wear appropriate PPE and monitor the atmosphere. Criteria are also applied to define the extent of the warm zone, and for a chemical incident, the National Exposure Standard value is often applied. In the case of a radiological emergency, the value may be from 2 to 10 microsieverts per hour. There is no equivalent value for application at a biological incident. The cold zone is the area surrounding the warm zone and is where facilities and operations are located to support operations in the hot and warm zones. When establishing the cold zone, use natural features such as trees, fences, and establish controlled entrance, exit points, and emergency exit points. Criteria are also applied to determine the extent of the cold zone. The concentration of contaminant within the cold zone is at normal background levels. The ambulance service support functions located in this area include triage and medical treatment areas. These areas need to be close to the exit of the decontamination corridor. Other ambulance operations include a transport corridor for patient removal and sheltered holding areas for casualties who have been successfully decontaminated. The police service support functions are located in this area and include the Police Forward Command Post, Media Liaison, Forensic Specialists, Security, and other specialised units. The fire service support functions, including Command Post, Dressing Area, Rehab Facilities, etc., are located in the cold zone. There might also be other agencies in this area, such as Salvation Army, SES, and the Australian Defence Forces.